Welcome to Layer Lines Weekly. I'm Alex, and I'm here with Jordan. So, I had one of those weeks where I was nursing a 14-hour PETG print. It was looking beautiful at hour 13, and then I woke up to a bird's nest the size of my head. But that's why we're here, to keep each other sane. On the docket today, Stratasys just bought Markforged for pocket change. There's a new $185,000 metal printer that either a steal or a trap, and a really cool AI from Oak Ridge that might save me from my own late-night print catastrophes. Jordan, what's grabbing you?
The acquisition, easily. $42.5 million for Markforged. I still can't get over that number. Nano Dimension paid something like $180 million for them not that long ago. I need to know where the bodies are buried. And I'm side-eyeing that was $185K metal printer, hard dose. You don't get two lasers and a 300 millimeter build volume for the price of a nice car without, well, we'll get into it.
All right, let's get into it then. Big story this week. Stratasys signed a deal to acquire Markforged from Nano Dimension. All cash, $42.5 million. That's the headline from both TCT and Voxel Matters. Now, Stratasys is a giant in the room, and Markforged has that killer composite and metal FFF tech. On paper, this sounds like a power move. For someone who runs a print farm, why should I care?
Well, first, let's just sit with the price tag, $42.5 million. Nano Dimension acquired Markforged in, I believe, 2023 for something north of $180 million. This is a fire sale, which makes me ask, what did Nano Dimension break? Or what did they discover that made them want to offload it at a 75% loss? That's the kind of discount that suggests the roof was leaking.
Right, that's not a gentle depreciation curve. But for the people running these machines, the Onyx printers, the Metal X systems, Stratasys has a big support network. Couldn't this actually be a safe landing? They're not a hedge fund trying to flip it. They actually know how to build and sell printers.
True, but Stratasys has a complicated track record with acquisitions. Remember when they bought MakerBot? That didn't exactly end with everyone singing Kumbaya. And Origin, the resin platform, that integration is still working itself out. The worry for a print farm operator is simple. Will my materials suddenly cost twice as much? Will my service contract get harmonized into something much more expensive? Stratasys has a reputation for premium consumables pricing.
Okay, so maybe don't pop the champagne yet. But there's another weird carve-out, the metal binder jetting line. It's explicitly not part of the deal. What happens to that?
That's the biggest red flag in this whole thing. If the technology had a clear path to profitability, Stratasys would want it, or someone else would have bought it alongside, leaving it behind with Nano Dimension, who just showed they're willing to sell at a huge loss. Suggests that binder jetting unit is effectively orphaned. If you bought into that system, I'd be very, very nervous right now. It's a tough technology to make reliable and economical, and now it lacks a deep-pocketed parent with an interest in keeping it alive.
Yeah, that's a grim read. And the deal isn't closing until the second half of 2026 anyway, which is over a year of uncertainty. Do you just freeze your purchasing decisions if you're a Markforged shop?
In an ideal world, no. But practically, you'd be foolish not to have a contingency plan. We saw this in the 2010s with a bunch of smaller 3D printing companies getting acquired. Support would just evaporate overnight. I once worked with a shop, a small one, just a few machines, whose primary vendor got absorbed. Within 6 months, they couldn't get a replacement hot end, not a proprietary one, just couldn't get it. They were stuck. So yeah, the interim period is when things get messy.
So the takeaway for anyone with skin in the game is hope for the best, but maybe stock up on spare print heads and filament while the old supply chain still exists. And for Stratasys, they get a solid installed base and some really clever composite IP for a bargain basement price, if they can integrate it without stepping on their own toes. I'm cautiously optimistic, but you've successfully made me cautious.
That's my job. Cautious optimism is the sweet spot.
Speaking of cautious, let's hit a couple hardware and material stories. First up, a company called Mastrix just launched the MX300, an industrial laser powder bed fusion metal printer. Dual 500-watt lasers, 300 by 300 by 350 millimeter build volume. And the price? $185,000. I saw that and did a double take. That's less than half what big brands charge.
Yeah, my alarm bells went off immediately. A dual laser PBF system from a company with no track record at a price that undercuts EOS or SLM by at least 200 grand, you have to ask, where are the corners being cut? Is it the laser quality, the gas management system that keeps your powder from turning into a fireball? Is the industrial part just marketing, or can this thing actually run 24/7 with consistent part quality?
That's the catch, right? The sticker price is one thing, but the total cost to run a metal PBF system, you need sieving stations, vacuum cleaners rated for reactive metals, possibly an argon supply. Voxel Matters noted that the company's claim about lowering the barrier to entry is speculation, because the printer is only maybe 30% of your real spend. So is this a breakthrough or a doorstop?
We've seen this movie before. Multiple low-cost metal printer entrants launched with big promises and then couldn't deliver the reliability. In metal AM, downtime is astronomically expensive, far more than the finance payment on the machine. If the MX300 needs constant babysitting, you haven't saved a dime. I'll cheer when they show me 10 customer sites with a year of solid data. Until then, it's a very shiny press release.
Fair. We'll watch that space. In a totally different corner, Oak Ridge National Lab developed an AI system that watches large format polymer prints and corrects errors in real time. No human needed. As someone who just lost a 13-hour print, this feels like a personal lifeline. Detect a layer shift or a blob, and the printer adjusts on the fly.
It's a great research demo, and ORNL is legit, and you knew there was a but, this isn't commercial yet. The article from 3D Printing Industry doesn't give quantitative results. Can it fix a partial delamination or only tweak flow rates? Most catastrophic failures in large format are mechanical. A stepper skips, a belt slips. Can AI on a camera fix a physical problem? Probably not. It might just pause the print and ping your phone, which is still useful, but not magic.
And finally, quick hit. Decathlon's running brand Kipron launched a 3D printed sneaker, the Kipnext 3D, using HP multi-jet fusion. This is interesting because Decathlon is huge and famously affordable. If they can bring the price of a 3D printed midsole down to earth, that's a real signal for consumer AM. But no pricing yet, so we'll see.
Adidas tried that with Futurecraft and mostly walked it back. It's still a niche. I'll get excited when I can buy a pair for under $100. All right, let's move to the factory floor, where things are decidedly less hypothetical. Norsk Titanium just signed their first recurring production contract with Northrop Grumman for structural aircraft parts using directed energy deposition. This is the real deal. We're not talking about a one-off qualification part. This is serial production of flight hardware for one of the biggest defense contractors on the planet.
I saw this and thought, okay, cool, another press release about a partnership. What makes this one different from all the other "we're working with a major OEM" announcements we see every month?
The word recurring, in aerospace, that's the holy grail. It means they've survived the gauntlet of material qualification, process qualification, part qualification, which can take 5 to 7 years, and the buyer has signed up to take a steady stream of parts. It validates DED as a legitimate manufacturing process for critical structures, not just for repair or cladding. That's a huge vote of confidence.
But how many parts are we actually talking about? Recurring production contract could mean 5 parts a year or 5,000.
We don't know the volumes. And the aerospace industry is famously slow to ramp, but even a small number is significant if the parts are structural, like if this fails, the plane falls out of the sky kind of parts. Norsk has been chasing this for years with Boeing and others. Landing Northrop Grumman first is a breakthrough. It also begs the question, where are those other prime contracts? Did they fizzle, or is this just the first domino?
And for the rest of us not building fighter jets, it's a marker that DED is maturing. The machines are getting better. The process control is tighter. It's not just a lab curiosity.
Exactly. It's an industrial process now with all the paperwork to prove it.
So on the complete opposite end of the spectrum, that ORNL AI story got me thinking about us mere mortals with our desktop printers. We can't have a supercomputer watching our prints, but what we can do is set up a cheap webcam and a Raspberry Pi running Octoprint with something like the Spaghetti Detective. I had a 12-hour print fail at 3 a.m. last month, and if I just had that running, it would have paused it and saved me half a spool of filament.
Yeah, it's a good stopgap. Just be careful with the sensitivity settings. If it's too twitchy, you'll get 100 false alarms from a shadow, and you'll end up ignoring it. I'd run it for a few days in monitoring only mode, first to see what it flags before you let it kill a print automatically, and make sure your printer's firmware handles the pause. command gracefully. Some old boards will just leave a hot nozzle sitting on your part.
That's a solid tip. It's not real-time error correction like Oak Ridge, but it's a fraction of the cost, and it's available right now. Worth a shot.
Let's talk about Connexu Sciences. They just debuted on the NASDAQ as a preclinical biotech company that claims its platform can architect bioregeneration. That phrase is doing a heroic amount of work because, as 3D printing industry noted, they have 0 approved products, 0 clinical trial data. It is a hype balloon, and I need to know if there's any helium in it.
Okay, but bioprinting is a tough field. If we waited for every regenerative medicine company to have a product on the shelf, we'd never fund any of them. Going public early could be a way to raise the $100 million you need to even get TAUs to clinical trials. Is it automatically a scam because it's early stage?
No, but the pattern is worrying. Preclinical biotechs with grand platform language and no specific disease target often go public to give early investors an exit, not because the science is ready for prime time. Architecting bioregeneration isn't a scientific term. It's a marketing slogan. And frankly, how much actual 3D printing is involved, the AM angle might be tissue engineering at best, not bioprinting as we know it. I'm calling it signal, high hype, signal 0, until we see a peer-reviewed paper or an FDA filing.
That's a fair line. I'd love for this to be the one that cracks it, but you're right. Show us the data. For now, we watch, but we don't invest. That brings us to our one thing to try this week. Take any old USB webcam, plug it into a Pi running Octoprint, and set up the Spaghetti Detective plugin. Let it watch your next overnight print. You might save yourself from a bird's nest catastrophe. Jordan, anything to add?
Lighting matters. Make sure the print is well lit, otherwise every shadow looks like a disaster. And if you're printing in black filament, you might need to dial the sensitivity up because the AI struggles with low contrast blobs.
Good call. All right, that's our show for this week. Thanks for hanging out with us. Go print something cool, and we'll catch you next week on Layer Lines Weekly.